So in this part of the 4.7 notes videos, we're going to be looking at a couple of examples here. We're on page 129 in the student journal. So the first type of question that we'll look at is evaluating these piecewise functions. So we want to remember that this piecewise function has two different equations defining the y values depending on what value of x we're using. So this domain restriction part up here, that tells us that when we're using an x value that is less than or equal to 1, y values come from the equation 3x minus 1. But if we start using any x value that is greater than 1, now the y values come from a different equation. So we have to be careful which part of the function we're using. So when you see this function notation, I'm being asked to find f of 0. So what that means is that we are using x equal to 0. So we need to ask ourselves, well, first of all, which function are we using? I see f and g. There's two different piecewise functions here. So this says function f, so I don't need to worry about function g for this question. That is not something I need to consider. The other part is which equation, which piece of function f are we going to be using? So notice that we're using x equal to 0. 0 is less than or equal to 1. That matches the top domain restriction. So that means we have to use the top equation to evaluate when x is 0. We can't use the bottom one because this one is only true when the x value that we're using is greater than 1, and 0 is not greater than 1. So I'm using the 3x minus 1. So 3, whatever x is, minus 1. Remember, function notation means that we're going to take that x value and substitute it into the equation for x. So I'm really just doing 3 times 0 minus 1. Well, what is 3 times 0? That's 0, and 0 minus 1 is negative 1. So we just found that for function f, when we use an x value of 0, the y value is negative 1. If I were using f of 1, which equation would I use? I'm still in function f. The x value is 1. 1 is less than or equal to 1. 1 is not greater than 1. So again, we are using the top equation in function f because that x value works for the top domain restriction. So 3 times x, well, we're using 1 for x, minus 1. 3 times 1 is 3. We still have to bring that minus 1 down. So the end result, or we could say f of 1 equals 3 times 1 is 2. There's our final answer. For number 3, that x value, is that less than or equal to 1 or greater than 1? 5 is greater than 1, so that means that we use the bottom equation from f of x. So for f of 5, now we're using the 1 minus 2x, again because this x value is greater than 1. So 1 minus 2, not times x, we're using 5 for x. So 2 times 5, that's 10. So 1 minus 10. 1 minus 10 is negative 9. So that means f of 5 is negative 9. It's a little different in number 5 here. Number 5 says we're going to use function g. So we need to consider the domain restrictions here in function g. The top equation is only true when x is less than or equal to negative 3. The middle equation is true for all values between negative 3 and 1. And the bottom equation is true only when x is greater than or equal to 1. So here we're using 0 for x. So that means that I'm in between negative 3 and 1. So I need to use the middle equation in function g. So let's see. The middle equation is g of x equals 2. Well, there's no x's to use to substitute here. So that means that for all the x values between negative 3 and 1, g of x is always 2. Okay, let's look at the next one. If x is going to be negative 3, does negative 3 work here? No, it's not bigger than or equal to 1. Does it work here? No, x has to be greater than negative 3, not the same as, but for the top one, x is less than or equal to negative 3. So that because x is less than or equal to negative 3, that means we need to use not the bottom one, the top equation. So for number 6, we're going to use 3x minus 1. But we're not using x. We're using negative 3 in place of x. So 3 times negative 3, that's negative 9. Bring the negative 1 down. Negative 9 minus 1 is negative 10. So we just found that g of negative 3 equals negative 10. When I look at number 7, g of 1, that 1 is only going to work for the bottom equation when x is greater than or equal to 1. So we're using the bottom equation in function g. Negative 3 times x. Well, we're using a 1 for x. So negative 3 times 1 is negative 3. So now we know g of 1 equals negative 3. If I were using g of 3, I'd be doing the bottom equation again, because 3 is greater than or equal to 1. If I was using negative 5, I'd be using the top equation, because negative 5 is less than or equal to negative 3. But it's the same idea. All we're doing is deciding which function, which piece of the function, and then we substitute that value in for x and evaluate. The other thing that we'll do with piecewise functions is make graphs of them. So give yourself an x and a y-axis here. Okay, now first thing I want to look at is what is my domain restriction. That's when x is 0. So that tells me that at 0, I need a dashed line that shows my boundary from one function to the next. When x is less than or equal to 0, so that's on the left side, I'm going to use this equation. When x is greater than or equal to 0, so to the right side of 0, I'm going to use this equation. So if I think about these in terms of slope-intercept form, the first one, I have the x term, so that would really be negative 4x plus 0. So my y-intercept is 0. I'm going to leave an open circle there for now. Negative 4 is my slope, so negative 4 over 1. So that would be down 4 to the right 1. But this one is only valid on the left side. So instead of going down and right, I need to go up 1, 2, 3, 4, and left 1, and I still have a negative slope. There's my first line using slope-intercept form to graph. My second line does not have an x term, so that's the same thing as 0x plus 4. It's a constant function because slope is 0. The y-intercept would be at 4. 1, 2, 3, 4. And rise of 0 means it doesn't go up, it just goes horizontal. The y value is always 4 when we're to the right of 0. And then which one needs to be filled in on the boundary? Well, that's the one for the equation I graphed first, because less than or equal to means filled in circle, but we know that from previous content. So I'm going to add that there. It's left of 0, and that's my filled in point. Okay, so number 11, same idea. Where's my domain restriction going to be? It's going to be when x is at 2. So that means that I'm going to make my y-axis over here, move it over a couple spots to make sure I can fit everything in. So x-axis, y-axis. Here's my domain restriction. So I'm going to go to 2 on the x-axis, and I'm going to put a dotted line there just so that I can see where I switch from one to another. Okay, my first equation, when x is less than 2 or left of that dashed line, the y-intercept is 4, the slope is negative 1 or negative 1 over 1. So this line would start at 4 on the y-axis, and it has a slope of negative 1. So down 1, right 1, down 1, right 1. And I left that point open on purpose. So there's my first line, left of 2, and I have a y-intercept of 4 and a slope of negative 1. My second line, here's where it gets tricky. The y-intercept is 3, which is here. However, I can't put any points for this line here because they only show up when I'm on the right side of that x value. So I just need to map out where it would be. So I would start at 3. What's the slope there? It's positive 1 over 1. So that then would be up 1 over 1, up 1 over 1. Now I can start putting points. Up 1 over 1, up 1 over 1. So there's my second line. I just have to be really careful not to show it left of the domain restriction boundary. And then finally, here's my or equal to, so that's my filled in point. Okay, thank you for watching the 4-7 videos. Have a great rest of your day.